to represent various other organisations such as the ELHP and the Mathsjam Time Travel Division. I'm here on behalf of DOCTIAL this year. You may never have heard of DOCTIAL, but some of you may discover during this talk that you are members of it. I'd never heard of it until earlier this year, until I was preparing another talk, but I was distracted by page 1 of a book I read while preparing the talk, and that's what led to my journey towards DOCTIAL, so that's what I'll tell you about today. Several years ago, somebody at Brighton Mathsjam asked what group theory was useful for, and we all looked at each other shiftily and couldn't come up with an answer. The best I could do was to say that in combinatorial game theory, when you look at misère games where you win if you can't move, about 20 years ago, Planbeck and Siegel discovered that you could apply things called commutative monoids to solving this problem, and this was real progress. Now, if like me you'd never heard of monoids before, it might help you to know that semigroups are things which are mentioned in passing in group theory courses and never heard of again, at least in my limited experience. And they're a set with a binary operation which is associative. If it also has an identity, then it's a monoid. If it has inverses as well, then it's a group. And all of these things can be commutative, or if they're groups, you call them abelian groups. So we've got 6 mathematical things which we're talking about here. Don't worry if you don't understand the details, because that's not where this is going. How many of these are there? Obviously there are more restrictions on groups, so there are going to be more of the less restricted things than there are of groups. Let's start with size 0. Well, you can't have groups or monoids of size 0 because you've got to have an identity element. And opinions differ on the subject of semigroups. Some people say semigroups have to be defined on a non-empty set, but Wikipedia and various other places seem to be happy with the empty semigroup. And I think it's amusing to consider a binary operation on an empty set and say, yeah, that's a semigroup, why not? Let's go with that. It's funnier than saying it isn't. And semigroups are clearly leading here by 1 compared with the 0 for some of the other categories of things. Size 1, well, there's only one of any of these of size 1, and it's basically the same thing every time. Not very exciting so far. N equals 2, well, there are rather more semigroups than there are groups, but it's not terribly impressive. N equals 3, there's only one group, and it's commutative or abelian, as we like to say. Semigroups looking quite good there with 18. N equals 4, not bad, not bad. I'm starting to be impressed. 5, 1,160 semigroups of order 5 compared with one group. 6, 15,973. I mean, we're into the raising one eyebrow kind of territory at this point, I think. 7, 836,021 semigroups of order 7 compared with a whole one group. Now, one thing you do when doing group theory is they say, you know, if you can identify some properties of the group, you can narrow down which one it has to be if you know its order, because there's not that many candidates. I can't see this working quite so well with semigroup theory at this point. And now, the thing on page 1 of the book on semigroups that led to my realisation that DOCTIAL existed. Order 8, there are 1.8 billion semigroups of order 8. I think a reasonable reaction at this point is, crikey. Although I would also accept a gosh, bože moi, santinomi, and things like that. And hence, the department of crikey. That is a lot. And that's what DOCTIAL is. And I think the author of my book on semigroups was clearly a member several decades ago, and I realised looking at page 1 of this book that I too was a member, and I think some of you may have just discovered that you are as well. But since this book came out, there has been progress. So using the online encyclopedia of integer sequences, I can reveal that n equals 9, I'm not even going to try to read that out, and n equals 10, well, what can I say really? And that's all I have to say on the subject. Thank you.